Today. Polynomial expression is a special form of algebraic expression. It is made up of two words. First one is Greek word poly, which means many, and we have the Latin word nomial, which means names. In mathematics, we can call it terms. So polynomial literally means many terms. So since we are talking about terms, let's try to understand the form of the polynomial, which is made up of different terms. So in the example, the first example that I have, it is made up of three terms. Let me try to highlight those terms. The first term is 9x raised to the power 5. Second term is 2x. The third term is a constant, which is 22. Each of these terms is separated by a positive sign in this particular case, but it could also be a negative sign, as we will see in the next example. So in the first example, we have three terms: first term, second term, and the third term. So it is a three-term polynomial. Let's look at the second example. It is made up of two terms: 7x square and 19x. It has two terms, and it is separated by a negative sign. So a polynomial its terms could be separated by plus or minus, a positive sign or negative sign. Both are fine. So this has two terms. This particular polynomial expression has two terms: 7x square and 19x. So, and it has a two-term polynomial. It is a two-term polynomial. Let's look at another example, the third example. So this is 18x raised to the power 100. So it has a single term, and therefore we'll write 1 over here. Now, polynomial term, the number of terms in the polynomial could be anything. It could be more than 3, it could be 100. The examples that I have chosen has only up to 3 terms, and they have special names. Each of them have special names depending on what is the how many terms each has. So let's start with the last one. So 18. This has one term. It is called mononomial. Mono, which stands for 1. So 1 nomial, as we have talked about before, it is term. The second one has two terms. So it's called bi, which means 2. Bi means 2. This one, the first example, has 3 terms. So it is called tri, which stands for 3. Trinomial, 3 terms. So this is some of the special cases of the polynomials, and I explained the number of terms in a polynomial expression. Let's look at a polynomial expression, an example of a polynomial expression, a little bit closely. So this is 9x square 2x plus 22. It is made up of 3 terms. Let's investigate its first term, 9x raised to the power 5. Let's try to investigate what is its form and try to learn some of the terminology associated with a polynomial expression. So the first term, 9x raised to the power 5, if you see its form is number 9. In general, it could be any constant. It could be 1, it could be 1.5, it could be any number, a constant. And then a variable which is raised to the power an integer. This is a typical form of your polynomial term, a term in a polynomial expression. So 9 here is called, which is the constant, the first constant that we have. It's called coefficient of that term. So this is the first term of the polynomial expression over here, and its coefficient is 9. Its exponent, which is the power that a variable is raised to, is called exponent of this term. Now, if you let's define the degree of this polynomial expression. So 9x raised to the power 5 plus 2x plus 22. What is the degree of this polynomial expression? So degree is the highest component that you can find in any of these terms. So this one has 3 terms. If you look closely, the highest power that you see is 5. The other ones are 1 or 22. It's x raised to the power 0. That is equivalent to exponent of 0. So the highest exponent that this expression has is 5. So this polynomial expression that you see, here, it has a degree of 5, because the highest exponent that you can 5, which is the first term 9x raised to the power 5, defines the degree of the polynomial expression. Let's take some more example to understand the coefficient, exponent, and degree a little bit better. So let's quickly look at the exponents. So the first term, let's look at the first term. First term has an exponent of 7. The second term has an exponent of 19, or rather minus 19, because it has a negative sign. So it has 2 terms. The coefficient of the first term is 7. Coefficient of the next term is minus 19. If you look at the exponent, so what you have to look at is the variable in each of these terms, and you have to see the power that this variable is raised to. So in this first expression, there is nothing on the as the power of x, but by default it is 1. So this has an exponent. This term has an exponent of 1. The next term doesn't have anything, so by default it is x raised to the power 0, which is basically equivalent to 1. So you can say that this term, 19 minus 19, has an exponent of 0. So if you see this whole expression, polynomial expression, the highest degree that the variable is raised to is 1. So this is a degree 1 polynomial expression. Let's look at another polynomial expression, 3u square minus 19. So if you see the polynomial expression, let's look at the first term. The coefficient is 3. The second term coefficient is minus 19 again. And if you see the exponent of each of these terms, so the first term has an exponent of 2, second term has an exponent of 1. It's not raised to power anything, but by default it is 1. So the highest exponent that we can find in this polynomial expression is in the first term, and that is 2. So we're going to put a degree. We say that this polynomial has a degree of 2. Similarly, I mean, if you do this exercise, the third expression has the highest exponent in the first term. We're going to call this degree 3 polynomial expression. Now, depending on what is the degree of the polynomial expression, some of them have special names. So the first one is called linear expression, because it has a degree of 1. So it has a degree of 1. So it's called a linear polynomials, because x is not raised to the power anything. Its maximum power that x is raised to is 1, which is basically a linear expression. The second one is called quadratic equation, because the highest degree that you see in this example is 2, and its a special name is quadratic polynomial. The third one is a cubic polynomial. It's a 3. In general, the degree could be anything, any positive integer. In this example, we have just talked 1, 2, 3, but it could be 100. It could be any positive integer larger than 100 as well. So this was an example to understand the coefficient, the exponent, which is defined for each of the terms in the polynomial expression. The polynomial expression overall has a degree, and depending on the degree, some of them has a special name. We have learned about linear polynomial expression, quadratic polynomial expression, and a cubic polynomial expression. So far we have talked about some of the examples of polynomial expression, but we haven't strictly defined what polynomial expression is. So let's see some of the example of what is a polynomial expression and what is not a polynomial expression. So all of these are algebraic expression, but some of them are polynomial expression, like we will see, and some of them are not polynomial expression. So the first example, what you see here is that if you see the exponent of each of these terms, so these are integers. 5, it's a positive integer. Here it's 1, it's positive integer. And here you don't see it explicitly, it's x raised to the power 0. So here none of the number is a fraction or non-integer or a negative number. So if you see in the example on the right hand side, here exponent of the first term is -5. It's a negative number, and therefore this is not a polynomial expression. If any of the exponent in any of the term is either a negative or a number that is not integer, then that's not a polynomial expression. Similarly, if you look at the second example, it is under root of 7. So no problem. The coefficient of any term could be, it doesn't have to be integer. The coefficient doesn't have to be integer. What has to be integer is the exponent. So you have to look at the power. It should be positive number. It's 2 here, so it's not a problem. It is polynomial equation. But if you see the second example on the right hand side, x is raised to the power 0.5. So it's basically root x as so this is not an integer, and therefore this is not an example of polynomial expression, because its exponent is not it's not integer, or yeah, it's not an integer. If you look at the last and third example here, once again under root 7, no problem. The variable could be anything. If you look at the exponent of the first term, it is 1, so not a problem. It is integer, it is positive. So this is a polynomial equation. On the right hand side, it is raised to the power -1. So equivalently, you could write this as under root of 7 divided by x plus 51. So you can clearly see that if your variable goes in the denominator, its equivalent is the variable is raised to the power a negative number. So this is not a polynomial. This is not an example of a polynomial number. So I hope you understand the basic definition of a polynomial equation is that its exponent in any of the term should be a positive integer. It should not be a negative or it should not be a fraction. So let's learn about the evaluation of the polynomial. How do we evaluate any polynomial? So we have been given a polynomial 9x plus 2x plus 22, and we denote this as p. This is the name of the polynomial, and in the bracket we put x just to denote that this polynomial has a variable in x. That's what it means. So if you see that in this term you have x in the components. So this is one polynomial. Let's learn, like, if we have to evaluate this polynomial. So if someone says that what is the value of this polynomial px at x is equal to 1, so what we have to do, we have to substitute x with 1. So here we have 9, so 9 remains, multiplied by 1 raised to the power 5. So x is replaced by 1 now, because we have been asked to evaluate the expression at x is equal to 1, so 1 raised to the power 5. So this is the first term. Similarly, in the second term, you replace x with 1, so it becomes 2 times 1. In the third term, there is no x, so that's okay. You just so overall, if you do a simple math here, p1, the value will come out to be 33. So we say that this polynomial at x is equal to 1, polynomial at x is equal to 1, x is equal to 1. So we replace this by 1 because we have evaluated this polynomial expression at x is equal to 1. The value is 33. So this is as simple as that. You can put, so basically what you can do is that if you have been asked to evaluate any polynomial expression, you have to plug the value of x with the value that you have been specified for the variable. Another example, so we have a polynomial s as a function of t as a variable is equal to 4t minus 1. So our polynomial expression is 4t minus 1. We have been asked to evaluate at x is equal to 1 by 4. 1 by 4. So if you plug t with 1 by 4, I think you will get a number which is 0. So we say that, you know, at x is equal to 1 by 4, the expression becomes 0. So this is a 0 of a polynomial. I hope you like the video. Thank you.